Have you ever wondered if the universe is trying to talk to us, sending cryptic messages across the cosmic void, signals that reach us only in the briefest flashes of radio waves? Imagine a sudden, intense burst of energy, so powerful that in milliseconds it outshines entire galaxies in radio wavelengths, only to vanish as quickly as it appeared. These mysterious phenomena are known as fast radio bursts, or FRBs, and they have puzzled astronomers since the first one was discovered in 2007. But what are they, and could they be evidence that we are not alone in the universe? Fast radio bursts are incredibly short-lived pulses of radio energy, each lasting only a fraction of a second, yet carrying immense amounts of power. To put this into perspective, a single FRB can release as much energy in a millisecond as our sun emits in a whole day, and some even rival the total energy output of billions of suns. These bursts are observed from galaxies billions of light-years away, meaning we are witnessing events that occurred eons ago, a cosmic postcard from the distant past traveling through space to reach our telescopes. Scientists are fascinated not only by their intensity, but also by their unpredictability. Most FRBs appear once and never again, while a select few repeat at irregular intervals, adding another layer of mystery. How can we explain such immense transient energy? Several theories have emerged, ranging from the most conventional to the wildly speculative. Some researchers suggest that FRBs originate from magnetars, which are neutron stars with magnetic fields trillions of times stronger than Earth's. Imagine a star so dense that a teaspoon of its matter weighs as much as a mountain, spinning rapidly and flinging electromagnetic radiation across space, occasionally producing bursts that reach us as FRBs. Others propose cataclysmic events like the merger of neutron stars or black holes, cosmic collisions that release vast amounts of energy in a heartbeat. Yet, despite these plausible explanations, the scientific community has never fully pinned down a universal cause for all FRBs, leaving the door open to more exotic possibilities. And this is where speculation starts to edge toward the edge of science fiction. What if some FRBs are not natural at all? What if they are artificial, signals deliberately sent by an advanced extraterrestrial civilization? The idea might sound like the premise of a blockbuster movie, but it is taken seriously by some astronomers. After all, the bursts are incredibly precise and incredibly powerful, characteristics one might expect from a civilization attempting to communicate across interstellar distances. Scientists analyzing the patterns of repeating FRBs have noticed structures that hint at modulation, as if the bursts carry encoded information. Could we be detecting a cosmic Morse code, a message waiting to be deciphered? Imagine trying to interpret a radio transmission from a civilization that evolved millions of years before humanity even existed, a message crafted in a language and medium we may only begin to understand. The very thought sends shivers down the spine and challenges our perception of life in the cosmos. Of course, the natural explanations cannot be discounted. The universe is a violent and energetic place, filled with processes that stretch the limits of our imagination. Magnetars, for instance, are born in the aftermath of supernova explosions, remnants of massive stars that have ended their lives in catastrophic detonations. Their intense magnetic fields can twist and snap like cosmic rubber bands, releasing bursts of radio waves in random directions. Neutron star mergers, too, are violent dances of unimaginable gravity, creating conditions that can generate bursts of radiation detectable across billions of light-years. Each new detection of an FRB provides more data, slowly filling in the picture, but with each answer comes new questions. Why do some FRBs repeat while others don't? What determines their frequency and duration? Are there patterns hidden in the chaos, or is randomness the only rule governing these cosmic flashes? Observatories around the world, from the massive dishes of the Parkes Observatory in Australia to the highly sensitive arrays of CHIME in Canada, are scanning the skies continuously, hunting for these fleeting bursts. The data they collect is staggering. Thousands of FRBs have been catalogued, and yet each one feels like a clue to a cosmic puzzle we are only beginning to understand. One particularly fascinating discovery came from the repeating FRB known as FRB 121102, located in a dwarf galaxy about 3 billion light-years away. This burst repeats irregularly, sometimes sending hundreds of pulses over a few days, then falling silent for months. The repetition suggests a stable, persistent source, unlike a one-time cataclysmic event, raising tantalizing questions about the mechanisms behind it. Are we witnessing a star behaving in ways previously unimaginable? Or could this repetition indicate deliberate signaling? Theories about alien origins become even more compelling when we consider the energy and focus of these bursts. To transmit a signal across intergalactic distances with detectable intensity would require technologies far beyond our current capabilities, perhaps harnessing energy sources comparable to the output of a star or manipulating natural astrophysical phenomena for communication purposes. It forces us to reconsider what an advanced civilization might be capable of, blurring the line between science and speculation. And yet, caution is necessary. History is filled with instances where mysterious signals were later explained by mundane causes. For example, the famous WOW signal detected in 1977 sparked excitement as a potential extraterrestrial broadcast, only to remain unexplained for decades. Similarly, many FRBs may eventually be traced to exotic but natural astrophysical processes, highlighting the importance of rigorous scientific scrutiny. One way scientists try to distinguish natural from artificial sources is by examining the polarization and dispersion of the radio waves. Polarization tells us about the orientation of the electromagnetic waves, while dispersion reveals how the burst's frequency components are delayed as they pass through interstellar plasma. Some FRBs exhibit extremely high levels of polarization, suggesting a strong, ordered magnetic field at the source, a characteristic consistent with magnetars. Others display complex time-frequency structures, hinting at processes we don't yet fully grasp. The puzzle grows more intricate when we consider localization. Pinpointing the exact origin of an FRB is incredibly challenging due to their brief nature and the vastness of space. Yet advances in interferometry and real-time detection have allowed astronomers to associate certain bursts with specific galaxies, providing crucial context. For instance, FRB 1807116 was traced to a star-forming region in a galaxy 500 million light-years away, and its behavior has been observed to follow a 16-day cycle, an enigmatic regularity that has scientists both baffled and exhilarated. Could such periodicity be a natural astrophysical rhythm, or is it a pattern designed to capture attention, much like a lighthouse signaling ships? The human mind is naturally drawn to patterns and meanings, a trait that fuels our curiosity about FRBs as potential alien messages. This interplay between expectation and evidence, between imagination and observation, is what makes the study of FRBs so captivating. It challenges us to think beyond our terrestrial perspective and consider the vast possibilities that the cosmos may hold. And while the idea of alien origin remains speculative, it is grounded in genuine scientific inquiry, inspiring projects like the search for extraterrestrial intelligence to analyze FRB data for signs of encoded information. Imagine decoding a signal that represents an entire civilization's knowledge, culture, or even consciousness. What would that mean for humanity? What could we learn about physics, technology, and life itself from a civilization millions of years ahead of us? Yet even if FRBs prove to be entirely natural phenomena, they still offer unparalleled insight into the most extreme conditions in the universe. Each burst is a probe, carrying information about magnetic fields, plasma densities, and energetic processes in distant galaxies. They allow astronomers to test models of stellar evolution, neutron star behavior, and intergalactic medium composition. In this sense, FRBs are cosmic messengers, whether their origin is natural or artificial, and each discovery pushes the boundaries of our knowledge. The excitement surrounding FRBs is matched by the challenges they pose. Detecting and analyzing these bursts requires sophisticated technology and international collaboration. Telescopes must monitor vast portions of the sky continuously, ready to capture signals that appear without warning. Data pipelines process millions of events, filtering out terrestrial interference and false positives. The effort is monumental, yet the potential payoff, the understanding of fundamental physics or the detection of intelligent life, is profound. As we look to the future, new facilities like the Square Kilometre Array, SKA, promise to revolutionize FRB research, detecting thousands more bursts and allowing precise localization and characterization. With every new discovery, we refine our theories, challenge our assumptions, and marvel at the complexity of the cosmos. Perhaps one day, we will detect an FRB whose structure is unmistakably artificial, a signal that changes everything we know about our place in the universe. Or perhaps we will uncover the underlying physical mechanisms that naturally produce these incredible bursts, expanding our understanding of matter, energy, and the behavior of stars in ways we cannot yet imagine. Either outcome is exhilarating, offering a glimpse into the vast, dynamic, and mysterious universe we inhabit. Fast radio bursts, whether alien messages or cosmic fireworks, capture the imagination because they are fleeting, powerful, and fundamentally unknown. They are reminders that the universe is alive with phenomena that challenge our understanding, calling on us to observe, question, and wonder. They are whispers from distant galaxies, invitations to explore, think, and dream. Every FRB detected is a puzzle piece in the grand mosaic of the cosmos, a flash of insight into processes that occur on scales both temporal and spatial beyond human experience. And while we may not yet know their origin, the pursuit of answers drives science forward, forging connections between observation, theory, and the human desire to understand. So the next time you gaze up at the night sky, remember that somewhere light years away, a star might be flickering in a brief, powerful burst, sending energy across the universe in a signal we have only begun to decipher. Whether a natural cosmic event or the work of an intelligent civilization, FRBs challenge us to think bigger, look farther, and imagine the unimaginable. They remind us that the universe is not silent, that across the vast emptiness, events occur with power and precision beyond comprehension. The study of FRBs exemplifies the thrill of discovery, the tension between the known and the unknown, and the ever-present possibility that the universe holds secrets we are only beginning to glimpse. And as we continue to listen, to analyze, and to dream, we participate in one of humanity's greatest adventures, the quest to understand the cosmos and our place within it. So, keep looking up, stay curious, and join us on this journey through the universe. If you enjoyed exploring the mystery of fast radio bursts and want to dive deeper into the wonders of space, make sure to like this video. Leave a comment sharing your thoughts on the possibility of alien signals, and subscribe to Cosmic Horizon Hub to stay on the cutting edge of cosmic discoveries. The universe is speaking. Are we ready to listen?